Welcome, friends. So, today we are going to shift our gear to deploy our Docker image into the Azure environment. And in this particular environment, we will learn what exactly the Azure container instance is and how we can deploy our Docker image into Azure container instance. So let's get started. We are having the dedicated videos and playlists for the containers and Kubernetes. We are highly recommending you to go to the playlist for the Dockers and Kubernetes, Google Cloud Platform, and as well as we are slowly going to build the playlist for Azure and AWS systems as well. So we are highly recommending you to watch those. If you haven't subscribed yet this channel, we are encouraging you to subscribe. So let's get started. Azure Container Instances is a service offered by Microsoft Azure that allows users to deploy and manage containers without the need to manage the underlying infrastructure. So it simplifies the process of running containers by offering a platform as a service solution that abstracts away the complexities of virtual machines, orchestrators, or other infrastructure components that we generally see in the Kubernetes environment or somewhere else. We ran our Docker container in Google Cloud Platform where we use the Cloud Run system. So these Azure container instances are almost similar like Cloud Run, but there are some philosophical differences between these two services. So this Azure container instances is offered by Microsoft Azure. And few key features of Azure container instances would be like it is a serverless containers, fast startup times, pay-per-use pricing, flexibility and integration, scalability, and persistent storage. So when you talk about the serverless containers, ACI offers a serverless environment for running containers. Users can focus solely on their application code without worrying about the underlying server infrastructure. This means no virtual machines to manage, patch, or scale, enabling a true PaaS experience for containerized application. One of the standout features of ACI is its rapid startup time. Containers can be deployed and started within seconds, making it ideal for scenarios that require quick scaling for running transient workloads such as batch job, data processing, and testing environment. With ACI, users can only pay for the resources they consume. This includes CPU, memory, and storage calculated by the second. The pricing model can lead to significant cost savings, especially for workloads with variable resource demands or short-lived processes. Azure Cloud Instance supports both Linux and Windows containers, providing flexibility to run a wide range of applications. It also integrates seamlessly with other Azure services such as Azure Virtual Network, Azure Kubernetes Services, Azure Function, allowing for more complex and scalable architectures. ACI allows for easy scaling for containers. Users can specify the exact amount of CPU and memory resources required for their containers, and ACI will ensure that these resources are allocated and available. This flexibility supports both horizontal and vertical scaling of the applications. ACI supports mounting Azure file shares as persistent storage volumes. This feature is crucial for stateless application that needs to maintain data across container instances. Now, there are several use cases for Azure container instances like microservices, batch processing, development and testing environments, event-driven applications, continuous integration, and continuous development CI/CD pipelines. So, when we talk about the microservices, ACI is an excellent choice for running microservices architecture. Each microservice can be deployed as a separate container, and ACI can manage the scaling and lifecycle of these containers independently. When you talk about the batch processing, for batch jobs that needs to process large amount of data, ACI offers a cost-effective solution. Containers can be spun up quickly to handle the load and then terminate it once the job is complete, ensuring that users only pay for what they use. Developers can use ACIs to quickly spin up isolated environments for testing and development. This capability accelerates the development cycle by providing a consistent and reproducible environment. Also, this ACI works well with event-driven architecture. For example, Azure Function can trigger ACI to run containers in response to a specific events, allowing the automated and scalable processing pipelines. It's also be integrated into CI/CD pipelines to build, test, and deployment processes. This helps to streamline the software development lifecycle and ensures that applications are continuously tested and deployed in consistent environments. So, Azure Container Instances provide a powerful and flexible platform for deploying and managing containerized applications without the overhead of managing the infrastructure. Its fast startup times, pay-per-use pricing, and integration with other Azure services make it a versatile tool for a wide range of applications from microservices and batch processing to development environments and CI/CD pipelines. By leveraging ACI, organizations can accelerate their development processes, reduce operational costs, and improve the scalability and reliability of their application.
Thank you for watching this video. In the upcoming lecture, we will see how we can make the ACI in action. We will deploy the container from the Docker image we built in past and pushed into the Docker public repository. We will keep both database and the container application inside a private network and will try to access the Python container from a application gateway from external world. So, please stay tuned for this exciting demonstration. Thank you friends for watching this video. If you haven't subscribed this channel, please do it now, so that you can get notified when new videos will be available. Let's stay excited for next lecture. Till then, bye and stay safe.